Hello students, so in last video we learned how to plot family of ovals and we saw two special cases. One was rectangle and another was ellipse, and similarly we can plot for other powers, fractional powers, right? Today we are going to look for family of spirals. So let me tell you first how the spiral look. So here I am plotting, I'm just drawing a graph which can give you just idea what is spiral. So spiral is like something this, a graph which looks like this. So this is not a general spiral, it is a particular case. Spiral start at one point, and if you move on, so suppose this is x-axis, this is y-axis, fine, and if you keep on increasing the angle, the polar angle. So what is polar angle? The angle from the x-axis. So suppose this is phi. So if you keep on increasing this phi, you are not going to return to the same point, unlike to the circle. So what happen in the case of circle? Suppose you draw a circle. Circle look like this. So if you keep on increasing the phi, after interval of 2 pi, you will come to the same point where you started. But in case of spiral, this is not the case. If you keep on increasing the angle phi, you are not going to return to the same point. So what is the actual fundamental difference between this spiral and the circle? The fundamental difference, there are two differences. One is that this is a radial vector, and this radial vector and the tangent at this point, suppose this is a P point, you draw a tangent over here. So this is tangent T. So this makes 90 angle degree, right? But in case of spiral, this is not the case, where if you draw, suppose this is a point P, and if you draw a tangent here, so if this is a tangent, fine, so this is a radial vector and this is tangent vector. So this angle would not be exactly 90 degree. This is not exactly 90 degree. Fine. So this is one difference. Another difference is that as you keep on increasing phi, the length of this radial vector, this is the radial vector. Why we call it radial vector? Because it originates from the origin and it reaches the curve point. So this is a radial vector. So this radial vector, the length of this radial vector is not constant over the angle phi. So in case of circle, if the radius vector, the length of radius vector is actually called radius, and which is fixed. So this radius is fixed constant parameter for a circle. So if you increase this phi as you move on this circle periphery, as you increase phi, this length, which is actually the radius, is not changing, which is a constant of constant parameter of this circle. But in case of spiral, it is not the case. As you keep on increasing or decreasing the phi, the length of this radial vector will change, and at some point it will become infinity, and at some point it will be 0. So there will be one point where it will be 0 and there will be one point where it will be infinite. Fine. So in case of circle, the length of the radial vector, which is radius, is a constant parameter, but the length of radial vector in a spiral is not a constant parameter. So this is the difference. Okay, so if we want to derive the equation for this, so we know the equation for the circle from our 10 plus 2 knowledge. X square plus a square y square equals to a square, where a is the radius, which is constant, right? So this is also a special case of ovals, where you can write it in this form: x by a whole square plus y by a whole square is equals to 1, where, so in case of ovals there were two parameter a and b, here we make them equal. But in case of spiral, if you want to derive the equation for the spiral, general equation for the spiral, how would you do that? So let me first tell you introduce with the polar coordinate, so that everyone can understand. If the viewer is a graduation student, then he must know the polar coordinate to understand the spiral, and if the viewer is master student, then he can skip this part. So to know how the polar coordinate, the details of the polar coordinate, suppose this is a y axis and this is x axis. So this is x axis, this is y axis. So at some point, this is a point P, where we denote as a r theta or r phi. So x, y is a Cartesian coordinate system, and r comma phi is a polar coordinate system, where r is the radial length from the 0, 0 or origin, this is r, and this is phi. So here I have made two coordinate system, one is Cartesian and another is polar coordinate system. If we want to make a relation between the two, how we will make that relation? So this length is r and this is phi. So we will draw perpendicular over x axis like this. So this is phi, that's why this is r cos phi, and draw perpendicular over y axis, this is r sin phi. So in this way the both coordinate system are related, that x is equals to r cos phi and y is r sin phi, correct? We know the equation for the circle, this is the equation for the circle, right? So this equation, how this equation look like in a polar coordinate system, let us see. So x square plus y square is equal to a square, write this x r cos phi whole square plus r sin phi whole square equal to a square, where r square cos square phi r square sin square phi equal to a square, r square common, and this is cos square phi plus sin square phi equal to a square. So this is by this formula from trigonometry, you know this is 1. So this comes out to be r equal to a. So a is a constant, so radius is constant. So whenever it is written, so what is the equation of circle in a circle in polar coordinate system? It is r equal to a, right? So corresponding to this equation, fine. Now if we want to derive the equation corresponding to a spiral, what we have to do, I will just tell you how to derive. I will not tell full derivation here. I will just give you how to derive, because that the video will become very lengthy. So I am just give you a hint how to derive. I will just show you the derivation but not derive. I have already derived it. Circle look like this, fine, and in this circle, so this is a blue color circle and we have drawn a tangent. This is in a tangent, fine, and this is x axis and this is y axis. See, we have drawn a circle here. This is origin, and we have also drawn a tangent at point, suppose this is a point P. So at point P, where the circle intersect on y axis, at that point P we have drawn a tangent. Since in the case of circle this tangent makes 90 degree with the radius vector, so here it is making 90 degree with the y axis, fine. And with the, if this angle is d phi, if this angle is d phi and this is 90, using the trigonometric formulas and the equations that, and the constraint that the sum of the angles, interior angles of the triangles are 90. So with that help we have derived all the angles and just written down those angles in red color here. But since in case of spiral, this angle which I have this angle which I have denoted here by 6, the angle 6, in case of spiral it is not 90, so I just increase this angle by delta psi here. So as you can see here, this I have changed here, this here you can see I have made it angle 6, I have changed by pi by 2 plus delta psi. In this way I have derived all the angles again and written down here angle 2, angle 3, angle 4, and use the sine rule within the this triangle PQR. So within the triangle PQR, I use here this sine rule and use the approximation that delta psi square is 0, because delta psi is already small, so delta psi will be 0. And I also use dr d phi because this is a double differential, so I just keep on the term only the first differential term like dr d phi, not the term like dr d phi or d phi square or dr square. We have neglected just take the limit tends to 0 because those are very small. In that case we derived this equation. This is the equation of spiral. So I could have done this by hand here in the video, but that will take a long time, so I just give you a hand how to derive this equation is spiral, and you can just do it by yourself, fine. Okay, so if we know the equation of spiral, we can do many more things. So what is the equation of spiral, which you will derive by yourself, and you will find that the equation of spiral. So how you will derive? The first condition is that you have to consider that the angle between the tangent and the radial vector is not 90. If it is, so let me tell you one more thing. Suppose if we want to draw this equation phi equals to pi by 2, how will you draw this on plane polar coordinate? So let us draw it. This is x axis, this is y axis. So it says that angle phi, which is the polar coordinate, is constant. So the angle phi is constant. So phi equals to pi by 2. So this angle 5 equals to pi by 2, this is the angle, right, 5 pi by 2, the polar coordinate is the angle from the x axis. So from x axis the 90 angle is this. So this is actually the equation of y axis. Similarly, if it is told to plot 5 by 4, then this equation, this is actually pi by 4 equation, this is pi by 2, pi by 4 angle. So if you are told to plot this equation, you will plot like this graph. Simply, if you are told to plot r equal to 2, how will you plot this? So if you want to plot r equal to 2, this means that you have to make the radius constant. So this is constant. Radial, the r is the length of the radial vector. So this is constant. So this means that this r equal to 2, this is constant. So if you change phi, this must not change. So everywhere r should be 2 because r is constant given. Phi is not, information phi is not given, it means that phi is not constant. You will have to change it. Like in previous case, it was given that phi is constant, you draw pi by 4, pi by 2. Here it is given that radius is constant, radial vector, the length of the radial vector is constant, this is r equals to 2. Similarly, if it is given r equal to 4, how will you draw it? You will draw a circle of radius 4. So this is r equals to 4 curve. So this is r equals to 2 curve, this is r equal to 4 curve. This is r equal to 4, this is r equal to 2. So till now it is clear. But in case of spiral, neither the length of the radial vector is constant, neither phi is constant. Both are interdependent on each other. So the equation will look like, if you derive it by saying that the angle between the radial vector and tangent is not exactly 90, you will find that equation of spiral is r equal to r naught e to the power alpha phi minus phi naught. Okay, so this is thing where alpha is cot psi, where psi is angle between radial vector and tangent vector. Fine. So if psi is pi by 2, then cot psi will be 0. Then in that case r will be r naught e to the power 0. So something to the power 0 is 1, this means this r naught. So this is the equation of circle. But if psi is not pi by 2, then it is a spiral. So I think now you got the point, how the spiral look like, what is the difference between the spiral and circle, how to derive the equation. So to derive the equation, the hint is that the angle between the tangent and the radial vector is not 90, and you can derive as I showed in the previous PDF. So I didn't derived here fully. so that you can derive yourself, otherwise you will be spoon fed, right? Okay, so this chapter finishes here. I will start next chapter from the next video, and the next chapter is on the special integrals. So the integrals which we will be discussing in the next chapter will be the Gaussian integrals, Stirling's formula, etc. Fine. So thank you very much.